In this lesson, we're going to look at how to solve two-step equations. So when we were solving one-step equations, we were talking about inverse operations. Subtraction is the opposite of addition, division the opposite of multiplication. But when we've got two steps, we need to think about the order of operations, specifically when we have the multiply and divide and the add subtract. So those are the two we're going to focus on for this. So just like when we solve the one step, we're doing inverse operations. When we get into these multi-steps, we're going to be doing the inverse of the order of operations as well. So we're going to be going backwards. We're going to start at the add subtract and go towards the multiply and divide. So we're going backwards to undo what we've done. So for the first problem, we would undo any add subtract first. So just like with the one variable, we're going to find our variable and we're going to start on the same side as the variable. So we're going to start on this left-hand side. And I added 4 to that variable. So the opposite would be to subtract 4. Remember, we've got to keep it all balanced. So if I subtract 4 on the left, then I have to also subtract 4 on the right-hand side of that equal sign. A plus 4 and minus 4 makes 0, so that cancels out. We still have that 6x left on the left. Then I'm going to bring down that equal sign. And I'm going to combine these like terms. Negative 2 and negative 4 is negative 6. So now we've undid the adding and subtracting. Now we're going to undo the multiplying and dividing. So this means 6 times x. So the opposite is to divide by 6. Again, on both sides, the equal sign. 6 divided by 6 is 1. So I can say 1x or just x, because 1 times x is just x. And then I'm going to divide. Negative 6 divided by 6 is negative 1. Number 2. Again, find that variable. It's on the left-hand side, so we're going to start here on the left again. And we're going to first undo any adding and subtracting. So we've got this 7. It's a positive 7, so the opposite is a negative or minus 7. One's on the left of that equal sign, and one's on the right of that equal sign. And that's going to cancel out. Still have that negative 2x we have not used yet. Drop down that equal sign. 13 minus 7 is 6. Now we're going to undo that multiplying and dividing. We're multiplying x by negative 2, so the opposite is to divide by negative 2. Cancels out to be 1x or just x. 6 divided by negative 2 is negative 3. And remember, we can always plug in to check our answer. So let's do that for this one. So we had 7 minus 2, and then instead of 2 times x, it's 2 times negative 3. We plug our answer in. And does that really equal 13? So this is 7. Negative 2 and negative 3 makes positive 6. And does 7 plus 6 equal 13? It does, so we know our answer is correct. Number 3, again, let's find that variable. It's on the right-hand side this time. So now we're going to start on the right-hand side. And we have a positive 8, so the opposite is a negative 8. Remember, one's on the left and one's on the right of the equal sign to keep that balanced. It cancels out the 8s to make 0. 36 minus 8 is 28. Drop down the equal sign. And on the right, we have a negative 14p left over. And then opposite of multiplying p by negative 14 is to divide by negative 14 on both sides again. That cancels to 1p or just p is equal to negative 2. And if it helps, you can flip it around and say p equals negative 2. It's the same answer either way. Number 4, my variable's on the right-hand side again. It's being divided by negative 4, and I have an added 2. Remember, we're going to start with the adding and subtracting first. So minus 2 on both sides. We get 3 is equal to x divided by negative 4. Opposite of dividing by negative 4 is to multiply by negative 4 on both sides. Cancels to 1x, or just x, is equal to negative 12. And then again, remember, we can plug it in and check. So we had 5 plus 2, 5 equals 2 plus negative 12 over negative 4. Does 5 equal 2 plus, this gives me 3, and yes it does, so then we know our answer is correct. For number 5, I'm going to get rid of these decimals again. So like we talked about in the last lesson, if we multiply every single term by the smallest place value, then we can eliminate those decimals. So this is in the tenths place, this is in the ones, this is in the tenths, so the smallest one is the tenths. So then we're going to multiply every term by 10. So times by 10, times by 10, times by 10. And that moves the decimal 1 point over. So that becomes 7x plus 10 equals 52. You could just leave the decimals. You will get the same answer. But for me, this is a lot easier to do in my head when I have whole numbers. And then we can solve. So we're going to add or subtract first. So that's minus 10 to both sides. 7x equals 42. Then I'm going to divide by 7. And x equals 6. Now, 6 is the exception here because I can't subtract by 3 first because that 3 is trapped up here in the numerator. So if we think about what makes this problem confusing or different is that we've got a fraction here. So then let's simplify this first by getting rid of that fraction. So this whole thing is being divided by 2. So let's do the opposite to undo. Multiply both sides by 2. Multiplying and dividing by 2 is going to cancel out. So that just leaves me with my numerator of x plus 3 is equal to 12 times 2 is 24. Now I've got an equation I can solve. I'm going to subtract 3 from both sides, and x equals 21. And then if you want to make any notes on the left-hand side, we can remember to watch my signs. So if there's a minus sign, that could also be thought of as a negative. Maybe another note I want to make myself is to start on the side with a variable. And any other thing you want to remind yourself that you might want to look back at. So if you want to make a note about how we can get rid of decimals, if you want to make a note of how we can do a more complicated problem like this number 6, add those notes to the left-hand side over there.